So these are the content of my presentation. Let's see one by one. So first introduction. In introduction, uh, beams of different materials like aluminum, iron, steel, and fiber reinforced composite material are widely used in the structural purpose in civil, mechanical, and other engineering applications. So, because crack or damages is such an important phenomenon which needs to be studied closely for the safety of structures. If the presence of the crack in the structure reduces the stiffness of the structure, which in turns reduces the natural frequency of it. And the number of the cracks present in the structure, the position of those cracks and depths of the crack are the important parameters to change the natural frequency of it. And to the detection of crack is necessary to ensure that the structure is free from any defect or not. Various techniques are adapted for the prediction of the crack location and the crack depth and crack size. The finite element method is considered as a mathematical tool for the analysis of complicated structures. So, in this total 10 models of beams have been studied for natural frequency analysis, having different crack depth and location and the major natural frequencies of various beam models by using the Euler's beam model theory, FEM and FFT analyzer. So these are the objectives of my project, to calculate the natural frequencies of the beams by various methods. Second one is to compare the natural frequency of the beams for the different crack models. And last one, to identify the crack in cantilever beam by using fuzzy logic techniques. So these are the this is the literature review. In first, Power et al. Use the genetic fuzzing system for the damage detection in the beam and helicopter rotor blades. In that, the merits is the genetic fuzzy logic is one of the alternatives for the entity techniques, and it gives the demerits of this technique is it gives the approximate solutions. Similarly, Navi et al. In 2005, he used that crack detection in beam using the experimental model data and finite element model. And Charanja et al. In 2012 used that faults detection of a single crack beam by theoretical and experimental analysis. And the merits of this methodology is he used to locate the size and depth of the open craft in the beam and use the different end conditions. And in that, he didn't use the FEA analysis. And Pari and et al. In 2013, he used that coherent network techniques to get the location of the crack and size and depth of the open cracks. And the demerits of these methodologies, it requires the neuron weights be necessary and sufficient to cluster the inputs. So these are the uncracked and cracked beam model. So you can see here the cantilever beam with the transverse edge crack is clamped at the left end and free at the right end, and and has some cross section and some length like model in figure 1 and 2, that is uncracked beam and cracked beam. So in this particular case, is assumed to be open surface crack and damping is not being considered. So this is the general equation for transverse vibration, the Euler's beam theory. Here, E is the stands for the Young's modulus of the material. I is the moment of inertia. A is the area of cross section, and L is the length of the beam. C is the constant depending on the mode of vibration. And here the constant are C1, C2, C3. The C1 value is 0.56, C2 value will be 3.52, and C3 value will be 9.82. So by using this above equation, I found the different mode for cantilever beam. Here, 10 models have been studied for the natural frequency analysis, having different crack depth and crack location, and calculate the natural frequencies and mode shapes for the beam models using the beam theory equation. So you can see the RCD and RCL here, and I use for first nature, second and third nature frequency. Here RCD is nothing but the depth of the crack to the depth of the beam, and RCL is calculated by using distance of the crack from the fixed end to the length of the beam. So next is I have used the FEM or FE analysis to calculate the natural frequencies. So these are the result of FE analysis. Similarly, I have used a experimental setup to calculate the natural frequencies, and these are the results. So you can see the comparison of natural frequencies by three methods: theoretical, FEA, and experimental analysis. So I used here 10 models and I calculated RCD, RCL by using first, second, and third natural frequencies for three methods: theoretical, FEA, and experimental analysis. So next is I use that fuzzy interface system. In that input is a different mode of natural frequencies to the fuzzy interface system, and the output is crack depth and crack locations. So steps for the fuzzy model is first is fuzzy inputs, second is apply the fuzzy operator, third is apply the implication methods, and fourth one is aggregate all outputs, and then last is the defuzzify. So here the fuzzy controller. So I have to give the first, second, and third natural frequency as an input. Then it get fuzzy fire, and then next is fuzzy controller. I have to give the if and then rules here, and then defuzzy fire, and I'll get the output, that is RCL and RCD, that is relative crack location and relative crack depth. So these are the comparison of fuzzy logic parameters with the theoretical parameters. We can see that the results mostly same as you can see in the theoretical or fuzzy logic. Almost say there is some relative error, 0.52 or 0.09, but result are almost matching each other. It's less than the 10% is the deviation. And the conclusion, calculation of natural frequencies of the beams carried out successfully. Comparison of natural frequencies obtained by the three methods can be done successfully. And last one, crack can be identified by using the fuzzy logic technique. And these are the references I have used. Thank you.
So, Yogesh, you have presented the work. This is your MTech work or what?
MTech or sir?
MTech work. Okay. So,
Yes.
all figures and tables you have used in this study is from your own work.
Yes, sir.
Okay. Fine. So, those in which you are showing cantilever beam, go to that figure. You have drawn that.
This one?
Yeah, this one. You have drawn these figures.
No, sir. I used from the papers.
So that's what I'm saying. You have not given any reference. So please be careful about it.
Okay.
And
Yes, sir.
otherwise, it is okay.
Yeah.
Jatin, do you have anything to comment?
No, sir, you commented on this. I was also saying
Okay.
this.
Okay.
Yes.
Thank you. Thank you so much. Thank you, everyone.
Okay, sir.
I
Thank you,
think
sir.
all are done.
Yes, sir, all are done, sir.
Okay. Thank you. Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you.